Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to start new module 5, Engineering Materials. In this I am going to cover nanomaterials and Solgel synthesis process. In this session I am going to cover these topics: nanomaterials, nanoscale, synthesis of nanomaterials in the top-down approach and bottom-up approach, and nanomaterial synthesis by Solgel method. I am going to cover these topics in this session. First, we should know about nanomaterials. What are the nanomaterials? See, what are nanomaterials? Nano derived from a Greek word, nanos meaning dwarf or small. What is meant by nano? Nano means small or dwarf in Greek word. Nano is derived from it came from the Greek word, that is nanos mean dwarf or small. That is called nano. The prefix nano means 1 billionth or 10 to the power of minus 9. 1 billion or 10 to the power of minus 9. Therefore, 1 nanometer is 1 billionth of a meter. What is nano? Nano means 1 billionth of 1 meter or 10 to the power of minus 9 meter is called the nano. The prefix nano means 1 billionth or 10 to the power of minus 9 part of a meter, or 1 billionth part of a meter is called nano. Nanoparticles are the size between 1 and 100 nanometers in size. 1 to 100 nanometers. The nanoparticle size is 1 to 100 nanometers. The nanoparticle size will be 1 to 100 nanometers. The nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. In nanomaterials, 3 dimensions are there. In that, one dimension should be less than 100 nanometers. That is called nanomaterial or nanoscale material. The nanomaterials are of interest because at this scale, unique optical, magnetic, electrical and other properties emerge. Nanoparticles are very interesting because of their having unique optical and magnetic and electrical and other properties it will contain. These emergent properties have the potential for great impacts in electronics, medicine and other fields. Because of these emergent properties like optical, magnetic and electrical properties, these nanomaterials are very helpful in the case of electronics and medicines, and it shows great impact in these fields. Okay, what are nanomaterial? The nano derived from the Greek word, that is nano means dwarf or small. The prefix nano means 1 billionth or 10 to the power of minus 9 part of the meter is called nano. 1 power of 10 to the power of 9 and minus 9 meters is called nano, or 1 billionth part of the meter is called nano. The nanoparticles are the size of the nanoparticles are 100 to 100 nanometers and 1 to 100 nanometers. The nanoparticle size will be 1 to 100 nanometers. The nanoscale materials are defined as a set of substances where at least one dimension, in 3 dimensions, at least one dimension that should contain the size should be less than 100 nanometers. That is called nanoparticle. The nanomaterials are of interest because at this scale, unique optical and magnetic and electrical and other properties emerge. The nanomaterials should have unique optical and magnetic and electrical properties. Because of these emergent properties like electrical and magnetic properties, these are showing great impacts in the electronics and medicine and other fields of industry. Okay, these are the nanomaterials and applications of nanomaterials. Then nanoscale. The nanoscale is a incredibly small scale of measurement. What is nanoscale? The nanoscale is an incredibly small scale of measurement. It describes objects, process and phenomena that measure less than 100 nanometers in a size. The nanoscale is an incredibly small scale of measurement. It describes objects and process and phenomena that measure less than 100 nanometers in a size. To measure the nanoparticles or nanomaterials, the size should be less than 100 nanometers. That purpose we can use the nanoscale. To measure the nanoparticles, we use the nanoscale. A nanometer is 1 billionth of a meter. Now, what is nanometer? Nanometer is nothing but 1 billionth part of a meter is called nanometer, which means that the nanoscale is a incredibly small. The nanoscale is a incredibly small. By using this nanoscale, we can measure the size of the nanomaterials or nanoparticles. The prefix nano means 1 billionth or 10 to the power of minus 9. 10 to the power of minus 9 part of the meter. Therefore, 1 nanometer is 1 billionth of a meter. 1 nanometer nothing but 10 to the power of minus 9 meter. Okay. It's difficult to imagine just how small that is. So, here are some example. So, it is very difficult to just have small, the nanoparticles are very small in size. That 10 to the power of minus 9 part of the meter. So, these are the example. Atoms, molecules, DNA. The DNA size is 10 nanometers. Similarly, the molecule size is 1 nanometer, means 10 to the power of minus 9 meter size. Similarly, the DNA size is 10 to the power of minus 8 meters, nothing but 10 nanometers. The atom size is 1 angstrom, nothing but 10 to the power of minus 10 meters. These are the example for the nano scale or nano sized particles. Then nanomaterials. The materials of at least one dimension between 1 to 100 nanometer are known as nanomaterials. What is meant by nanomaterial? In the material, in 3 dimension, at least one dimension should contain, the size of the one dimension should be 1 to 100 nanometers. That material is called nanomaterials. Then nanoscience. What is nanoscience? Study of materials and their properties at the length scale of few nanometers is called nanoscience. What is meant by nanoscience? Study of materials and their properties. Study of materials and their properties, and at the length scale of few nanometers is called nanoscience. It is called nanoscience. Then definition of nanotechnology. The definition of nanotechnology. The techniques involved in the preparation, characterization and use of the properties of the nanomaterials in different applications are collectively called as nanotechnology. The techniques involved in a preparation, characterization and use of the properties of nanomaterials in different applications are collectively called as nanotechnology. The nanotechnology is nothing but the techniques involved in the preparation and characterization and use of the properties of the nanomaterials in different applications are called nanotechnology. And other definition also we have for nanotechnology, that is, it is design, characterization, production and application of structures, devices and systems by controlling their shape and size at nanoscale. It is a design, characterization, production and application of structures, devices and systems by controlling their shape and size at nanoscale. This is the definition for nanotechnology. What is meant by nanomaterial? The materials of at least one dimension between 1 to 100 nanometers are known as nanomaterials. What is meant by nanoscience? Study of materials and their properties at the length scale of few nanometers is called nanoscience. Study of materials and their properties at the length scale of few nanometers is called nanoscience. What is meant by nanotechnology? The techniques involved in the preparation, characterization and use of the properties of nanomaterials in different applications are collectively called as nanotechnology. Other definition for nanotechnology is it is design, characterization, production and applications of structures, devices and systems by controlling their shape and size at nanoscale. This is the definition for nanotechnology. Then synthesis of nanomaterials. Then how we can synthesize nanomaterial? The small sized particles are small sized 1 to 100 nanometers particles. How we can synthesize? Those are called nanomaterials. The synthesis of nanomaterials. See, there are two methods of preparing nanomaterials. There are two methods are there for preparing the synthesis of nanomaterials. One is top-down approach and the other one is bottom-up approach. There are two methods are for preparing nanomaterials. One is top-down approach and other one is the bottom-up approach. See, the top-down approach. The material is reduced from bulk size to nanoscale. Okay, in top-down approach, how we can proceed? The material is reduced from bulk size to nanoscale. Means in the top-down approach, you have to convert the macromolecule to micromolecule. Macromolecules means bulk molecular, bigger molecule. Bulk molecular, bigger molecule, we have to convert it into the micro by break down this. Okay, this bulk molecule we have to break to get converted into the nano sized particles or nano structures. In this top down approach, what you have to do, the material is reduced by breaking or some other method from bulk size to nanoscale materials. In this, the macromolecule converted into the macromolecule. So macromolecule converted into the micromolecule. This is the top down approach. In top down approach, you have to convert the bulk molecule into the nanoscale materials. The second approach is, example for the top down approach are ball milling method and nanolithography method. These are the example for the top down approach. In the top down approach, what are the example? The ball milling method and nanolithography method. These are the example for the top down approach. In top down approach, the bulk molecule should be converted into the small molecules or nanoscale molecules are called top down approach. Here macromolecules are converted into the micromolecules in the top down approach. The example for the top down approach are ball milling method and nanolithography. These are the example for the top down approach. The second preparation method for the nanoparticles is in bottom up approach. In bottom up approach, the bottom up approach is the second method for the preparation of nanomaterials. In the bottom up approach, matter in atomic or molecular level gets assembled to form tiny clusters which grow to reach nano size. In this bottom up approach, the matters like atomic or molecular level, molecular level particles, these are assembled together. Okay, the small molecules, the size of these atoms less than the nanomolecules. Okay, these atoms are assembled together, form a tiny clusters which grow reach to nano size. These small molecules are aggregate together, assembled together, form a clusters. These clusters lead to the nano structure. Here, in the previous case, top down approach, the macromolecules are converted into the micromolecules in top down approach. But in case of bottom up approach, the micromolecules are converted into the macromolecule. Here, the small atoms are converted into the clusters. These clusters leads to the nanoscale materials. In the bottom up approach, micromolecules are converted into the macromolecules. Okay, in the bottom up approach. The example for the bottom up approach are the chemical vapor deposition method and physical vapor deposition and Solgel method. These are the example for the bottom up approach. In the bottom up approach, we have to convert the micromolecule into macromolecule. In this, the atomic or molecular level gets assembled to form a tiny clusters. These tiny clusters leads to the nano size particles. The example for these bottom up approach methods are the chemical vapor deposition and physical vapor deposition and Solgel method. These are the example for the bottom up approach. See, in the top down approach, this is the bulk molecule. We have to convert it into the fragments. Again, we will get the nano structure. This is the top down approach. Up to here, top down approach. Here, macromolecule is converted into the nano particles. Here, in the bottom up approach, the tiny atoms are molecules. These are converted into the cluster, assembled together and forms a cluster. This cluster leads to the nano structures. Here, the micromolecules converted into the macromolecules in the bottom up approach. See, this is the top down approach. Top down approach means you have converted the bulk molecules into the tiny nano particles. In the bottom up approach, see, the tiny molecules atomic levels are converted into the nano particles. See, these are the example for the top down approach. See, what are the example for the top down approach? Mechanical milling, etching, laser ablation, sputtering and electro explosion. These are the example for the top down approach. What are those? Mechanical milling, etching, laser ablation and sputtering and electro explosion. These are the example for the top down approach. Similarly, for example for the bottom up approach, see, supercritical fluid synthesis, spinning, Solgel process, laser pyrolysis, chemical vapor deposition and molecular condensation and chemical reduction, green synthesis. These are the example for the bottom up approach. What are the example for top down approach? Mechanical milling, etching, laser ablation, sputtering and electro explosion. These are the example for the top down approach. And similarly, bottom up approach, supercritical fluid synthesis, spinning, Solgel process, laser pyrolysis and chemical vapor deposition, molecular condensation, chemical reduction, and green synthesis. These are the example for the bottom-up approach. See, the nanomaterials synthesis by Solgel process. The Solgel process is the example for the bottom-up approach, and these are the nanomaterial synthesis by you can synthesize nanomaterials by using Solgel process. In this method, how you can prepare nanoparticles, we will see. Solgel process principle is conversion of precursor solution into gel via hydrolysis and condensation reaction. In Solgel process, the principle is conversion of precursor. Precursor solution nothing but reactant solution. The solution which contain reactants or starting materials. The precursor nothing but starting material. In the Solgel process, you have to take a starting material solution. First, you have to convert this starting material solution or precursor solution into the gel form. Okay, by using hydrolysis and condensation reactions. By using condensation and hydrolysis reaction, you have to convert the precursor solution into the gel form. Okay, this is the principle of the Solgel process. What is the principle of the Solgel process? In the Solgel process, first we have to convert the precursor solution into the gel solution. Okay, first we have to convert the precursor solution to the gel solution by using these methods, hydrolysis and condensation reaction. By using hydrolysis and condensation reaction, you have to convert this precursor solution into the gel form. This method is mainly used for preparation of metal oxide nanomaterials. The Solgel process mainly used for the preparation of metal oxide nanoparticles. This method is preferably used for the metal oxide nanomaterial synthesis. The example, by using Solgel process, we can prepare zinc oxide nanoparticles. Titanium dioxide nanoparticles can be synthesized by using this method. By using Solgel process, we can prepare zinc oxide nanoparticles, titanium dioxide nanoparticles, and other metal oxide particles by using this Solgel method. It is good example for bottom-up approach. This Solgel process is the example for bottom-up approach. In this micromolecules, we have to convert into the macromolecules. This is the example for the bottom-up approach. Solgel process is the example for the bottom-up approach. It is a wet chemical technique. In this, for preparation of Solgel process, we have to use water or solvents. So that is, it is called wet chemical technique. Solgel process is a wet chemical technique. See the Solgel process. First, we have to convert sol. Okay, we have to convert sol into the gel, and gel then have to dry it, then grinding, then stiffing. The final product will be in nanoparticles. We will get nanoparticles at finally. See, the following steps are involved in the synthesis of nanomaterials by Solgel process. These are the steps are involved in the Solgel preparation of nanomaterials. The Solgel nanomaterial preparation, these are the steps involved. See, the first step, preparation of sol. The first step is preparation of sol. First, we have to prepare sol. In this method, metal alkoxide is used as a precursor to synthesis nanoparticles of a metal oxide. Okay, first in this method, first we have to take precursor solution. The precursor nothing but we have to take metal alkoxide. Okay, corresponding metal oxide we have to take that as a precursor. Suppose if I want to prepare titanium dioxide nanoparticle, for that we have to take titanium metal alkoxide. Titanium metal alkoxide we have to take. Okay, the metal oxide we have to consider as a precursor. If I want to zinc oxide nanoparticles, for that we have to take precursor zinc metal alkoxide materials we have to take as a precursor. In this method, metal alkoxide is used as a precursor to synthesize the nanoparticles. The metal alkoxide is dissolved in a alcohol and then water is added under acidic or neutral or basic condition. Then in that, first we have to take metal alkoxide precursor. Okay, this metal alkoxide precursor, first we have to dissolve in alcohol. Okay, first we have to dissolve this metal alkoxide in alcohol, and then for that you have to add water. Either you can use acidic or neutral or basic condition. Any condition you can use. The addition of water leads to the hydrolysis, in which alkoxide ligand is replaced with a hydroxyl ligand. For this metal alkoxide, when we added water, what happens? This addition of water leads to the hydrolysis, in which alkoxide ligand is replaced with a hydroxide ligand. See, metal alkoxide reacts with water, H2O. It forms, what happened? It forms metal hydroxide plus ROH, alcohol. This is called hydrolysis. The water is breakdown, that is called hydrolysis. The metal alkoxide is converted into the metal hydroxide. Metal alkoxide converted into the metal hydroxide and alcohol. Okay, in the first step, what happened? In the first step, we have to take metal alkoxide, that is we have to dissolve in alcohol solution. For that, we have to add water. The water reacts with this metal alkoxide, it forms metal hydroxide and alcohol. In the first step, preparation of salt. What is salt? Salt nothing but the dispersion of salt, aerosol, liquid salt. Like that, salt means the dispersion of solid in liquid is called salt. The dispersion of solid in liquid is called salt. Here see, the metal hydroxide, this is a solid. This solid is dispersed in the alcohol. Alcohol nothing but that is a solution. Okay, this metal hydroxide is a precipitate, that is solid, that is dispersed in this alcohol, that is called salt. In this step, first we have prepared the salt. Salt nothing but the metal hydroxide dissolved in the alcohol, that is called salt. In first step, we have prepared the salt. Okay. In the next step, the conversion of salt to gel. The next step, you have to convert the salt to the gel. See, the polycondensation reaction between metal hydroxide, the metal hydroxide and metal alkoxide, okay, results in the formation of an oxide, metal oxide metal, or alcohol, metal bridge network. Okay, that is called gel. The next step, the polycondensation reaction takes place between the metal hydroxide and metal alkoxide. It will form metal oxide metal or metal hydroxy metal. These bonds will be formed. Those are in gel state. The bridge network will form. Those are in gel form. That leads to the increase in the viscosity of the solution. Because of this bonds formation, there is an increase in the viscosity. If the viscosity increases, the solution converted into the gel. See, the metal hydroxide and metal alkoxide, these undergo polycondensation. In these two, the polycondensation reaction takes place and this forms metal oxide metal and alcohol. The polycondensation reaction takes place. So this bridge network is formed, that forms a gel, that leads to a gel formation. In the first step, we have prepared the salt. Then next step, the salt is converted into the gel. See, this is the synthesis of the nano particles by using Solgel method. See, precursor and solvents you have to take in this beaker. Then after, we will form the salt. Salt formation takes place. That is colloidal structure in solution. Means the solids are dispersed in the solution. That is called salt. These salt are again connected to porous structure. Again, it is converted to the porous structures. Okay, na? That is gel form. By using polycondensation reactions, it forms gel form. And this gel form by using different techniques, supercritical drying, that is form aerogel. If you use after gel formation, if you drying this gel, okay, na, the different types of drying process are there. We have to dry this gel. Okay, na, the first salt formation takes place, then gel formation takes place. After forming this gel, we have to dry this gel solution or gel liquid. By using different techniques, different types of gel formation takes place. By using supercritical drying, we will get the aerogel. If you using thermal drying, we will get cryogel. If you by drying with freeze drying, we will get zero gel. After then, if you grinding this anyone, we will get the final product of the nano particle. This is the synthetic procedure of the Solgel procedure. See, the third point is aging of the gel. Okay, in first step you have prepared salt, in next step you have prepared gel. In the third step is aging of the gel. The reaction mixture is allowed to continue polycondensation reaction until the gel transforms into the solid mass or gel or evaporation of solvent. The reaction mixture is allowed to continue polycondensation reaction until the gel formation. Okay, na? The polycondensation reaction we have to allow for the formation of gel. Okay, salt to gel. The time is called aging of the gel. The reaction mixture is allowed to continue the polycondensation reaction until the gel transform into the solid mass. Evaporation of solvent takes place and gel formation takes place. That is called aging of the gel. The fourth point is removal of a solvent or drying of a gel. Removal of a solvent or drying of gel. The water and other volatile liquids are removed from the gel network. Okay, na? Gel formation takes place in that solvent particles also there. So the water and other volatile liquids if present in the gel, okay, those can be removed by using the, you have to remove those excess water and solvent from the gel network. Okay, that is called drying of the gel. If isolated by thermal evaporation, the resulting product is termed as a zero gel. If for the drying, the gel is dried by the using this technique, thermal evaporation, the product will be formed zero gel. If the solvent is extracted under supercritical condition, resulting product is termed as aerogel. The final one, the final point is heat treatment. The sample obtained is calcinated at high temperature, around 800 degrees centigrade. Okay, na? After gel, after drying the gel, okay, the dried gel is then heated at, calcinated at high temperature above 800 degrees centigrade. Okay, na? Then to obtain the nanoparticles. Nanoparticles formed by the Solgel process commonly have size ranging from 1 to 100 nanometers. After calcination above 800 degrees centigrade, we will get the dried powder. Then we have to that if you crush that one or grinding that the gel, then we will get the nanoparticles within the range of 1 to 100 nanometers. This is the procedure for the preparation of Solgel process. First you have to take precursor, then precursor converted to the sol, then sol is converted into the gel, then gel is dried by different methods. Okay, then we have to grind, then we will get the nanoparticles. Okay, these are the different methods: spinning method, gel method, cone method. Okay, these are the methods. After calcination, we will get the nanoparticles. The advantages of the Solgel process. See, what are the advantages present with the Solgel process? The main advantages of the Solgel process are the high purity of the product will be obtained. By using Solgel process, we can prepare the high purity of the nanoparticles we can synthesize. The narrow particle size distribution. In the Solgel process, there is a size distribution is very narrow. The achievement of uniform nanostructures at low temperature. At low temperature, we can get the uniform nanostructure materials we can prepare by using low temperatures. The disadvantages of the Solgel process. The disadvantage of the Solgel process, see, the cost of the raw materials or the starting materials will be high. Okay, the precursor solution cost will be high in the Solgel process. The applications of Solgel method. See, the materials obtained from the Solgel method are used in various optical, electronic, energy and surface engineering, biosensors and pharmaceutical and separation technologies such as chromatography. In this field, we can use the nanoparticle obtained from the Solgel method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.